The most advanced space telescope ever built is the James Webb Space Telescope. In this video, we'll go over how this telescope works, how it was designed and built in different places around the world, and we'll explore the launch and journey into space. My name's Hanan. I create 3D animations to show and explain how things work. If you'd like to support these videos and see behind the scenes on Patreon, then stick around until the end of the video. Looking up into the night sky, we can only see reflecting telescopes so much with the naked eye. When we get away from the city and other lights, we can see a little bit better. If we want to see even more, then we'll need to use a telescope. This allows us to see much farther and clearer into the night sky. There are several different types of telescopes, but in this video, we'll look at a simple reflecting telescope. This uses mirrors to capture and direct the light. Light comes in and hits this large curved mirror, then bounces and focuses the light on a smaller secondary mirror until it comes into the eyepiece for us to view or a camera to record the images. Think of it like collecting rain. The bigger your bucket, the more rain you're going to collect. The larger the mirror, the more light it collects, and the more distant objects you'll be able to see. A space telescope uses the same concept, but on a much larger scale. Time machine looking into the vastness of space is a bit like looking back in time. Let me explain. Light travels fast, but it doesn't travel instantly. Light from the sun takes about 8 minutes to get to Earth, covering a distance of 149 million kilometers. If something were to suddenly happen to the sun, we wouldn't know it for 8 minutes. The closest star to us is just over 4 light years away. That means we're seeing Proxima Centauri as it was 4 years ago. Think about looking at other stars that are thousands, or even millions of light years away. With a powerful enough telescope, we can see galaxies that are billions of light years away. It's like a time machine. We're looking back into the universe as it once was. This helps scientists answer some very deep questions. It might also help us understand more about Earth and why it formed the way it did. Telescopes on the ground see light only put it in space after it passes through the atmosphere. The atmosphere contains shifting pockets of air that can distort images and actually can stop some forms of light from reaching the ground. You can solve some of these problems by putting telescopes high up in the mountains. We call this an observatory. But to see things really clearly, scientists have put telescopes high above our atmosphere. But getting anything into space is challenging and expensive. There's been quite a few space telescopes over the years, different sizes and launched for different reasons. Just note that this is not a complete list by any means. The most famous one you're probably familiar with is the Hubble Space Telescope. Hubble was launched in April of 1990, aboard the Space Shuttle Discovery. Enchanting music, it was a 5-day mission in orbit around the Earth. The 5 NASA astronauts on board worked together to deploy the Hubble Space Telescope. Hubble is in low Earth orbit. It's about 540 kilometers above the surface of the Earth. When we look inside this telescope, we can see that light comes in and bounces off the primary mirror. The light goes to the secondary mirror, and then gets redirected through the center to the scientific instruments in the back. These images are then captured and relayed back to Earth. Hubble was able to see much farther into the cosmos than ever before. In December of 1995, they did something that is now called the Hubble Deep Field. Scientists pointed Hubble at an area of the night sky that looked empty. As far as we knew, there was nothing there. They focused on the same spot for days at a time to reveal as much light as possible. What they found was incredible. It was completely filled with distant galaxies. Moments like this changed astronomy. There is so much out there to see. Because the Hubble Space Telescope is in low Earth orbit, astronauts could return to Hubble to make repairs and maintain the telescope. There have been 5 servicing missions, with the last one being in 2009. Each time the space shuttle would catch up to the Hubble Space Telescope and make the needed repairs. Then the astronauts could open it up and repair or replace parts inside of it. The last servicing mission was in 2009. The space shuttle then retired in 2011. There isn't really another option to repair Hubble. As of December 2024, Hubble is still operational, but it's unknown how much longer it will last. It was well known that there were limits on what Hubble could see, no matter how long it stares at the same place. Light spectrum. It turns out that light shines in different wavelengths. They call this the electromagnetic spectrum. You already know some of these. Larger wavelengths for radio waves to listen to music and smaller wavelengths to see if a bone is broken in your body. The human eye can only see a very small portion of this spectrum. Our eyes interpret these different wavelengths as colors. The rest of this light we cannot see, at least not without the right instruments. A good example is thermal vision goggles. Watch what happens when we take a look through them. I can see there is a person inside of the house. The goggles allow me to see the infrared light. Essentially, it can see the heat of different objects. Either way, that light is still there, but without the goggles, humans can't see it. Infrared light is just above the visible light spectrum. Hubble is an optical telescope, which means it's mostly capable of seeing the same as human eyes, but much more sensitive. But the scientists have long understood that if we only look at the visible light spectrum, we're missing a lot of the picture. The James Webb Space Telescope, sometimes called JWST or just Webb, was launched in December 2021, making it relatively new. It is an infrared telescope, allowing it to see past the visible light spectrum and detect things that even Hubble cannot. Our understanding of the universe suggests it is expanding, with galaxies moving away from each other. When galaxies are far enough away, their light waves lengthen due to the Doppler effect, shifting visible light into the infrared spectrum, a phenomenon known as redshift. This makes these distant galaxies invisible to optical telescopes like Hubble, which primarily sees visible light with some infrared and ultraviolet capabilities. Webb was specifically designed to observe these distant objects, essentially looking back in time to understand the early universe. For example, while Hubble might only see the outer layers of stellar nebulas, Webb's infrared vision can penetrate the clouds and reveal incredible details. Unlike Hubble, which orbits the Earth, Webb is positioned about 1.5 million kilometers away, 4 times the distance of the Moon. It resides near a Lagrange point, a region in space where gravitational forces are balanced, requiring less fuel to maintain position. Specifically, Webb is stationed at L2, an ideal spot where it remains close to Earth while avoiding interference from the Sun's light. Because it detects infrared light, Webb's instruments are highly sensitive to heat, including their own, and must be kept extremely cold. Unlike Hubble's traditional tube-shaped design, Webb features a large, diamond-shaped sunshield roughly the size of a tennis court, composed of 5 ultra-thin layers, each about as thick as a human hair. These layers help block heat and sunlight, ensuring the telescope remains cool and effective. Webb will always be pointed away from the sun. Any exposure could damage its delicate instruments. Below the sunshield is the spacecraft bus, which contains electronics, communication, and propulsion systems. The telescope itself consists of 2 main parts, the ISIM at the back and the OTE at the front. The primary mirror comprises 18 hexagonal segments, a design chosen for its ability to fit together without gaps while folding for launch. This segmented approach allows for a much larger mirror than Hubble's. Light collected by the primary mirror is directed to a secondary mirror before entering the telescope's instruments, which include 4 specialized scientific tools, each designed for different observational purposes. These instruments enable Webb to detect some of the oldest and most distant objects in the universe, study star and planet formation, and even observe celestial bodies within our solar system. The idea for Webb began before Hubble's launch in 1990 when scientists gathered to discuss the next-generation Space Telescope. However, progress was slow, and construction did not officially begin until 2004. The project faced numerous delays and was nearly cancelled in 2011. Despite these setbacks, teamwork across multiple organizations helped bring Webb to completion. The telescope was finally launched in 2021, with a projected lifespan of 10 years, though scientists hope it could last at least 20. Webb is an international collaboration involving NASA, United States, the Canadian Space Agency, Canada, and the European Space Agency, with contributions from multiple countries. The hexagonal mirror segments were manufactured at various locations in the U.S., with final assembly in Boulder, Colorado. These segments are made of beryllium, chosen for its lightweight and durable properties, ensuring it holds shape in the extreme cold of space. Each mirror is coated with a thin layer of gold, which is highly reflective of infrared light. The assembled mirror segments were then transported to Greenbelt, Maryland, where they were integrated into the telescope. Meanwhile, the sunshield layers were built in Huntsville, Alabama, before being shipped to Redondo Beach, California. Since the sunshield needed to be compact for launch, engineers designed it to fold efficiently within the rocket. The telescope's primary structures, the OTE and ISIAM, were both built at NASA's Goddard Space Flight Center in Greenbelt, Maryland. The assembly process required extreme precision. Engineers used a robotic arm to install each mirror segment over 3 months carefully. Once in place, workers in a clean room meticulously removed the protective covers to prevent contamination or scratches that could impact performance. The scientific instruments were then installed, collectively referred to as OTIS. Once complete, OTIS was packaged into a specialized shipping container known as STARS and transported via AC-5 aircraft to Houston, Texas, for rigorous testing at NASA's Johnson Space Center. There, OTIS underwent cryogenic vacuum testing inside Chamber A, the world's largest high-vacuum chamber, where it spent approximately 100 days in conditions mimicking deep space. Following successful testing, OTIS was repackaged and flown to Redondo Beach, California, for final assembly at Northrop Grumman, completed in August 2019. The launch site for Webb was the Guiana Space Center in French Guiana. To transport the fully assembled telescope, NASA had to modify the shipping container, creating an even larger version called SuperSTARS. The telescope was meticulously folded to fit inside its launch vehicle, and once in space, it would undergo an intricate unfolding process. Every stage of Webb's journey, from concept to launch, required immense international collaboration, cutting-edge engineering, and years of dedication. First, it traveled by road, pulled by a big truck, going very slowly, of course, as there was some precious cargo on board. This time, instead of traveling in an airplane, it was loaded into a cargo ship to travel by water. It traveled from the coast of California down through the Panama Canal and over to French Guiana, taking 16 days to make the journey. This is the Ariane 5 rocket, owned by the European Space Agency, with 2 side boosters, a main stage, an upper stage, and the payload fairing. This is where the telescope was stowed. The finishing touches happened inside the final assembly building. The telescope was lifted up, moved over, and carefully installed at the top of the rocket. Then came the payload fairing. It was time to move the rocket to the launch pad. Going into space is risky. We have extremely delicate cargo that will be violently shaken during the launch. After that, it will be exposed to the cold vacuum of space. This is a big part of why it took years to build and test. There's only one chance to get this right. The Ariane 5 rocket is a proven launch vehicle, the perfect choice for such a delicate mission. The launch took place on Christmas Day 2021. At about 2 minutes and 21 seconds after liftoff, the solid rocket boosters ran out of fuel and detached from the spacecraft, falling back into the ocean. The main stage carried the rocket upward. At 3 minutes and 26 seconds, the payload fairing detached, revealing Webb seeing space for the first time. At about 8 minutes and 48 seconds, the main stage separated from the rocket. Then, the upper stage ignition began, with the engine burning for about 16 minutes, putting Webb on a path away from Earth. At 25 minutes, the upper stage shut down, and shortly after, the telescope separated. It was finally on its own, heading toward its final L2 destination. However, it would take about a month to get there, with the telescope slowly unfolding over 2 weeks as it traveled through space. All of this was closely monitored by teams of scientists in Baltimore, Maryland, at the Mission Operations Center. Now, let's go over the major milestones of the deployment. First, the solar array unfolded, a very important step to power the telescope. Then, the high-gain antenna deployed to improve communication with Earth. It took only about a day and a half for Webb to travel past the Moon's orbit. Next, The unitized pallet structure, or UPS, unfolded, followed by the deployable tower assembly, which increased the distance from the sun shield, helping the sensitive instruments to cool down. The aft momentum flap was deployed to help keep the telescope stable in space. Then, the sun shield was deployed, an extremely delicate process that took several days to fully complete. The secondary mirror was deployed, followed by the aft deployable instrument radiator to help keep the temperature down. Next, the primary mirror was deployed, first the port side, then the starboard side. Before the telescope could be used, a process called mirror phasing had to be completed. The 18 hexagonal mirrors needed to be adjusted with tiny movements until they were precisely aligned. This process took many weeks to complete, but once finished, the hexagons acted as one giant mirror. Unlike the Hubble Space Telescope, which could be serviced by astronauts if something went wrong, Webb was too far out to be repaired. Similar to the Mars rover, it had to be designed with extreme precision because a repair mission would not be practical. Everything had to work the first time. The first images from Webb were released on July 12, 2022, marking a major success, and many new discoveries have since been made. We are learning new things about the universe that no one expected. As of December 2024, Webb has been operating successfully for almost 3 years. A total of $10 billion, 30 years in the making, and thousands of scientists and engineers came together to make Webb a reality. Now, we stand on the edge of even more discoveries. What mysteries of the cosmos and our own origins will James Webb uncover next?